All right. Good afternoon once again. We have a question from Agegave, and this is Engineering Mechanics One, and it's a source from on one of the difficult questions I have. So the question read: the tension in a cable AB in the figure above is 100 Newton. Determine the moment about O of this tension as applied to point A of the T-shaped bar. So this is a T-shaped bar. We have to find the moment of the force T or the tension T. So to do that, quickly we have to draw the free body diagram for this tension, right? Then remember the dimension from here to here is B over 2, from here to here is B over 2, from here to here is B, and then from here to here is B. And the value of B was given to be 600 millimeter here, and the value of this tension is given to be 100 Newton. So we'll quickly draw the free body diagram for this bar. The free body diagram for this bar looks like this, right? It looks like this. You would have on your T-bar, inclined at an angle, looks like this, and then it's in the shape of T, so you get this, right? So this is the T-bar. Then this is the point at which is hinged, point O. Then from there you extend it to this place, you get point B. So this is point B, and then where else? The tip of this bar here is point A, isn't it? So you would have this is B over 2, that is from here to here is B over 2. Then the length of this, that is from here to here, is B, right? Then from here to here is also B, right? Right. So you join this because there is a cable joining A and B. You join these points A and B together to get that, and then the tension points this way, so you have that to be the tension T. All right. So without further ado, we delve into solving this. Okay, I left something. There is an angle of inclination of the bar to the horizontal is given to be 60 degrees. From here you can see that this angle is 60 degrees, so from we will have to include everything. So this is the free body diagram of the structure, and remember your B is equal to 600 millimeters, right? So if B is 600 millimeter, we have to take note of that when solving. So quickly what we'll do is we'll give this an angle. As you should still remember from your treatment of moment, if this is an angle of inclination to a line that joins the line of action but then is not at right angle to the line of action, if that is inclined at an angle to the line of action, then the moment of this tension force about point O, denoted by MO, would be given by T multiplied by the distance, this B sine theta. Why is that? Because we know that moment is the force times perpendicular distance. So B sine theta is the perpendicular distance to the line of action of this force. So if you take an imaginary line here, this distance, because this is perpendicular, if you take your sine of this angle, sine will give you this distance D. I don't want to write it bold so that, because I want to make some construction and I don't want that to like make the work dirty. But then if you take the sine of angle B, you get that to be equal to D divided by B. So if you look for D, like what I'm saying is sine theta would give you D divided by B. So your perpendicular distance D is equal to B sine theta, right? So in that case, you get your D to be B sine theta, and then you know that moment is equal to force times that perpendicular distance D. So that's why we'll have T times B sine theta. So from there, we'll call this equation 1. Then we'll look for the value of sine theta. Now, finding the value of sine theta is like the bulk of the work that we'll be doing here. So this is the strategy you are going to employ. We are going to construct a line parallel to this very line, right? This very line, the shape of the bar, we're going to construct a line parallel to it. So construct that line parallel to it to get to this point, right? Then we also construct a line parallel to this very line to meet the initial line we constructed. So these are constructed lines, they don't come with the figure, right? So remember, if this is parallel to this, then and this is parallel to this, then this and these distances are the same. So this is also distance B. So from here to here is equal to B, right? And then let me name this point C, and here point D, right? So we have here this point where this line meets this line to be point C. So if that's the case, what we want to do is we want to find this length A AD. Want to find the length AD. Already we know that AC is equal to B, but then we don't know CB yet. Sorry, CD yet. So we'll look for the value of CD to get this length. Then we'll apply our cosine rule to get this angle and then proceed. So how do we get this distance? Remember, this is equal to 60 degrees. This is 90 degrees by the virtue of a rectangle, because it's actually a rectangle, because these are two parallel lines meeting each other. So this is 90 degrees, this is 60 degrees. 90 plus 60, that will give you 150. Then if you subtract 150 from 180, you get 30 degrees. So this angle is 30 degrees. So if we know that, and then we know that this from here to here is equal to B over 2, this is B over 2, then that means OC is equal to B over 2. If we know that, then we'll proceed. Take the tan of this angle, the tangent of this angle, 30 degrees. Know that tan 30 would give us, tan 30 is opposite divided by adjacent. Opposite is CD, that's CD divided by the adjacent. What is the adjacent? OC. So remember, this is a right angle triangle with the hypotenuse, the opposite, and the adjacent. Then we are looking for CD. Like we said, our CD becomes OC tan 30 degrees, and so that would be equal to OC already is B over 2, that's B over 2 tan 30 degrees, right? So B over 2 is 600 divided by 2 tan 30. Then you end up with 600 over 2 tan 30, you get 173.4 millimeters, right? So that's the value of CD. All right, if we have the value of CD, then we should use that to get the value of AD, because we know that AD is equal to AC plus CD. So that will be equal to AC from here is equal to B plus CD is equal to 173.4. And we know the value of B already. From here, we know that B is 60 millimeters. So from there, we get, 600 millimeters, 600 plus 173.4. And then we end up with 773.4 millimeter. So that's the value of AD. And then if we know that, then we'll also look for the distance DB. All right, so the distance DB, we know that DB from that diagram could be equal to OB minus OD, right? That is from here to here minus from here to here will give you from here to these points. That's DB, right? So do we have OB? We know that that will be equal to OB is the distance B, because we said it's from here to here is B, which is 600 mm, minus OD. For now, we don't know OD, but then we can take the cosine of this angle 30 again, and then to get OB. So cos 30 would give you, cosine is adjacent all over the hypotenuse. So that will be adjacent, which is OC, divided by hypotenuse, which is OD. So we are making OD subject formula. Our OD becomes OC divided by cos 30 degrees. And that will be OD will be equal to, OC is B over 2, which is 600 divided by 2 divided by cos 30 degrees. So if you do that, if you do 600 divided by 2 divided by cos 30 degrees, you get 346.4. So you get 346.4 millimeters on your calculator. If you punch this on your calculator, you get that on your calculator. And remember, I said OC is equal to B over 2, 600 over 2. So in case you are confused, note that. So from there, if you get OD, then you proceed, because you can get, in that case, you could get DB to be equal to OB, which is OB is 600 minus OD. OD is 346.4. So if you do this very well on your calculator, you would get 253.6 millimeters, right? So we've gotten the value of DB. So from there, we'll quickly get our AB, because we are looking for the sine of this angle, sine theta. That's actually the aim. So we are looking for the sine of this angle. So sine, we use our cosine rule. From our cosine rule, we know that AB, that's on this triangle ABD. So AB squared is equal to, remember this angle should give you 120 degrees. You should all know why it's 120, because here is 60. This line is parallel to this line, so here is going to be 60. If you subtract 60 from 180, you get 120 degrees. So that's why here is 120. This is going to be 60. This is 60. So they are corresponding angles. So from here you get AB squared. AB squared is equal to, that's your cosine rule. Using your cosine rule, AB squared is equal to AD squared plus DB squared minus 2AD dot times DB cos 120, because this angle is 120. If you apply your cosine rule to that triangle very well, you get this formula or this expression. So we are looking for AB once again. So our AB squared will be equal to, what's the value of our AD? We just found the value of AD in this stage. AD is equal to 773.4 squared, plus what's the value of DB? DB is 235.6 squared, minus 2 times 773.4 times 235.6 times minus 1 over 2, right? Because we know that cos 120 is minus 1 over 2, or minus 0.5. So from here we get our AB squared is equal to, if you do add everything here on calculator, not if you use your calculator to evaluate everything here, you should get 858, 594.76, and that would be this. If you take the square root of both sides, you get AB to be equal to, if you take the square root of that, this number, remember this is a comma not a dot, you'd get 926.6 millimeters. So we'll get AB to be equal to this millimeter, right? So if we've gotten this, then next thing is you quickly want to get the sine of this angle. Use our sine rule. Know that sine theta all divided by that sine of this angle divided by AD is equal to sine of this angle here, this very angle 120, which is sine 120 divided by sine 120 divided by AB, right? AB. So you're looking for sine theta. Sine theta at the end of the day will give us AD sine 120 divided by AB, right? So that would be equal to AD sine 120. Remember our AD is equal to 773.4 times sine 120. That would give us times 0.866 divided by AB, and AB is equal to, from what we've calculated earlier somewhere here, okay, we've already gotten AB to be 926.6. So if you do sine theta at the end of the day, you would get sine theta to give you the value 0.7228. So if you get sine theta to be this, then remember our question was to find the moment MO. So substitute this into MO. We know that MO is equal to T times B sine theta, right? So that will be tension. Tension is 100 Newton, if you still remember. And what is B? That's 600 millimeter. So that's 600 millimeter in meter, because you have to convert that to meter. That's 600 divided by 1000, then multiply by sine theta, which is 0.7228. So at the end of the day, you get moment. If you multiply everything out here, you get 43.37 Newton meters, right? So this is the answer to your question. Thank you for watching. See you in the next video.